What section we're doing? Right here. Why is it a little odd? We skipped it, yeah, because what was the last section we did? We did 1-7. So we went over, we skipped, actually skipped 1-3 and 1-4. We're not going to do 1-4 at all. And this is kind of, it has a couple, it's important, but it has a couple of different things. So we want to do it after we did like all the solving equation stuff. So we're going to go over this, and then we're going to go into chapter 2. Okay, starting on, well, this one will take a couple of days, and then we'll go into chapter 2 on Monday. It's not necessarily fractions. They're a little different. We're going to talk about ratios. We're going to talk about rates. We're going to convert units and rates. Well, rates, that's something you do every day. As soon as you get in the car, you're going like 30 miles per hour. That's a rate. Okay? You're going 30 miles in how long of a time frame? 1 hour. Okay? If you're going 16 meters per second, you got to understand how that relates. Okay? And then ratios and proportions come up a ton. So first thing here, though, a ratio, okay, is a comparison. Okay, this isn't on your guide notes. Just pay attention here. A ratio is a comparison of two quantities. A proportion is an equation that states that two ratios are equal. That case there would be like 1/2 is equal to 2/4. Would you agree with that? Yeah, that would be a proportion. That is, it's got to be true. You just can't make numbers up. You cannot say 1/2 equals 2/8. Okay, 1/2 equals 2/4. 1/4 equals 3/12. Does anybody remember how to check to see whether a proportion is true? You can cross multiply it and you see if they're the same, because 3 times 4 is 12. 1 times 12 is 12. Then you know it's true. Equivalent ratios. Sometimes you'll see it written as a colon, A to B, and C to D. That would be like 1 to 2 is the same as 2 to 4. Okay, 1 to 2 is the same as 2 to 4. Or A over B is the same as C over D. I think that's what you're used to. Okay, so we're taking two ratios saying they're equal. Well, the key thing here is we're going to find missing pieces of ratios if we need them. So right here, x over 6 equals 10 over 12. You might be able to look at it and tell me what that x is. But how do we solve it if we don't? Okay, Addie?
You multiply x and 12 to get 12x, and then you take 12 and divide it by 6 times 60.
Yeah, we're going to use that fact that we just used. We said if we had a true proportion, you can cross multiply and they have to be equal. We're going to cross multiply, like Addie said, x times 12, but we always write that as 12x. Never write x 12. And then 6 times 10. I'm going to go ahead and just multiply them either in my head or in my calculator. So I get 12x equals 60. When you're done, all you got to do is divide by what? 12. And it'll give you the answer. So what is 60 divided by 12? 5. So we're making the claim that 5 over 6 is the same as 10 over 12. Well, some of you might have recognized that, well, yeah, if I reduce 10 by 2 and 12 by 2, I get 5/6. So it's got to be the same. This one you might have been able to figure out. The next one, I don't know if you can figure that one out just looking at it. You might be able to come close. 13 over p equals 5 over 4. So I can't figure it out exactly. Got to cross multiply. It really doesn't matter which order. 13 times 4 with 52. P times 5 or 5 times p, which is 5p. Now I divide by what? Always divide by the number with the variable. So Addie? Divide by 5. Divide by 5. And I get p equals, what's 52 divided by 5? 10.4. So 13 divided by 10.4 is the same as 5 over 4. Okay, we agree? So that's all you do with a proportion. Cross multiply, divide. Okay, that'll be the same. Now we use proportions for different things. One of them is an indirect measurement. Now this might have came up a little bit blurry on your paper. But take a look at this. It says, you can take the measurements shown in the diagram. The right triangles created by each object and its shadow are similar. The question they're asking is, can the tree fall into the house? Well, the first thing you got to do is find out how tall the tree is. So as you look at this, you see this person who is 6 foot tall has an 8-foot shadow. This tree has a 30-foot shadow, and I'm going to call this distance or the height of the tree X. How far is the tree from the house? Addie? 25 feet. Find the height of the tree. And do you know how to do this? How are we going to do this? Using the two triangles. Okay. Here's where proportions come into play. And there's different ways you can set this up. I'm just trying to see if anybody remembers from last year maybe what we would do. Okay. Anybody want to take a stab at it? Come on, Gavin.
Come on, you guys should do this.
Give me an attempt.
Six over 8. X over 8.
Okay, I'll take that. Now, there's more than one correct way to do this, and I'll show you here in a second. Basically, the height to the shadow has to equal the height to the shadow. That is correct. 6 over 8 has to equal X over 30. So if I set this proportion up, can I solve it? We just solved 2 of them right before that, right? So, Taryn, what do I have to do to solve it?
8 times X.
Okay, 8 times X, which is 8X. And then what else, Taryn? 6 times 30, which is 180. Go ahead and take 180 divided by 8, which is, I don't even know. What do you got, Griffin?
22.5.
22.5. Now, if you just go on to the next problem, can I count this right? No, because what do you still have to answer?
Can the tree fall onto the house?
Okay, will it?
No.
No, because you have 25 foot.
The interruption at this time.
Hurricane tornado.
7th graders.
Yeah.
Last
If it
name
uproots it.
with K through M. Please go to the performing arts hall now for your screening. That's 7th graders. Last names beginning with K through M. Go to the performing arts hall now and bring your eyeglasses. And that's it. Thanks.
Now, I don't think I'd chance it with 2.5 feet. That's not a whole lot of room for air. So I think I would make it fall the other way for that one if I'm cutting it down. All right, how else can I set up the proportion to still be correct? That's one way. Height over shadow equals height over shadow. You can also set it up. You can do height over height. 6 over X equals, and what would be the other one then? If I do 6 over X, it has to equal
8 over 30.
8 over 30, because then I do shadow over shadow. 8 over 30. That'll work. And that'll give me 8X again. 8 times X is 8X equals 180. I still get the same answer. Okay, so there's more than one way you can set up that proportion. There's wrong ways to set it up. You can't do height over shadow equals shadow over height. It has to be the same thing. Mason?
How do you get 22.5?
Just on the calculator. Well, I'm hoping to get it. 1 second, quit. 180 divided by 8. There we go. Just using the calculator for that one. So it will miss the house. All right, now the next one down there. Your friend is 5 feet 8 inches tall. Ooh, they're making it tricky on us.
Oh my gosh.
And it casts a shadow 12 feet long. At the same time, a nearby tree casts a shadow 54 feet long. A drone is stuck at the top of the tree. Man, we've got a lot going on here. What's the height of the tree? Can you use a ladder that allows you to reach a height of 21 feet to retrieve the drone? All right, let's draw the situation. Basically, you can just boil this down to 2 triangles. Here's your person. 5 foot 8, shadow's 12 feet long. All right, anybody see the problem we have right here with 5 feet 8?
There's inches and feet.
There's inches and feet. This is 12 feet. So how, and you cannot put 5.8 is not 5 feet 8 inches. Okay, so I think that's a lot of times is your common, go-tos. You're gonna say 5.8. So 5.8 is not 5 feet 8 inches. How do we figure that out? Okay, Griffin?
You multiply 5.8 by 12.
We can't use 5.8. Maybe I shouldn't have even given you that. Okay, you can't. You don't multiply 0.8 by 12. What do you multiply? Or you gotta be careful there. You're on the right track, but you're not there yet. All right, how do we convert that inches to feet? Not multiplied by 12, divided by 12. So you have 8 inches. How much of a foot is that? What's 8 divided by 12? So there's 12 inches in a foot. Now here's the problem. It's going to give you did we do it yet? 8 divided by 12 gives us a what?
0.66.
Gives us 0.6 repeating. I don't want to round off until the very end. What is that as a fraction? Okay, what does that reduce to? What'd you say, Danny?
2/3.
2/3. You reduce it by 4, so it's 2/3. So make this 5 2/3. Okay, make that 5 2/3. All right, we got our tree. How long is the shadow of the tree? Whoa. 54 feet, is that right?
Yes.
Thank you.
You're welcome.
We don't know how tall it is. All right, set up a proportion. What would we do for this one? Set up a proportion.
Just trying to help out.
You did. Carly, what do you think for a proportion? It's not 5 or x over 54 equals what? Not 8 over 12. What's the height of the person? 5 2/3. Let's see here. Okay, does anybody have something different? Because that's not the only correct one. Anybody else have anything different? Oh, come on. Okay, so if you got this, 54 times 5 2/3. Multiply that out. So you know how to enter 5 2/3 on your calculator?
Steve it. Use the Steve button.
What's the Steve?
ABC.
Oh.
It's the bow tie button.
Ooh, yeah, calculator. Abby, I'll put your phone up in 24. Because that's what we're going to start using. What's you give us, Jack? You got it?
190.
54. Nope.
Right.
180. Anybody else get 180? You got 180? All right, so how do you enter 5 2/3? So remember, you got to hit 5. Let's enter it. Hit 5, and then you hit the ABC button.
Or Steve.
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 And then 2, and then the ABC button, and then 3. And on your calculator, how does that look? Does it look like this? Does it look like that?
Everybody see it?
I did it differently.
You did it different. Of course you did it differently. Did you get the same answer? How'd you do it?
I did 5, and then in parentheses I did 2/3.
Okay, that'll work. Should work. Okay, let me switch it.
I did.
What?
I did.
So 5 2/3
I thought it
times.
was 54.
Yeah, it's not 180.
54 times.
2,
So I did it.
Yeah, it's 306.
50.
It's 306.
306. Yep, should be 306. So 5 2/3 times 54 is 306 equals 12x. Divide by 12. 306 divided by 12 gives me 25.5. So X equals 25.5. Now on my calculator, I think there's different ways you can do this. I can take 2/3. I do get a decimal. If I add 5 to it, that's 5 2/3. But if I multiply it times 54, since I didn't round everything off, it'll give me that nice whole number. So you want to keep it in a fraction as you can. 25.5. So can I use a ladder that allows me to reach a height of 21 feet to retrieve the drone? No, because the drone's how high? The drone is 25 feet. So the ladder's not tall enough.
Was the guy had no arms climbing it? I'm sorry. Stubby. Stubby, go get the drone.
You're wrong. All right, flip it over on the back.
Don't bob in the water.
Oh, Russell.
Get that one.
Leaves. It's in the leaves. Russell's around.
I never heard that.
No. All right. We talked about rates a little bit earlier, meters per second, and that. So you can compare two things. Now, if something are different rates, we have to be able to convert them and look at that. So take a look at this case here. The diagram shows statistics for a baseball pitcher. Use rates to compare the pitcher's performance in 2019 to his performance in 2020. Now, we need to tell you what rate to look at. So for this one here, because you can look at innings to hits, earned runs to innings, but we want to be specific. So we're going to compare strikeouts per walk and see which year was better. So strikeouts per walk. So strikeouts will go on top. So in 2019, he had how many strikeouts? 100. And then how many walks did he have that year? He had 29. So take 100 divided by 29. Okay, 100 divided by 29. And then, Ryan, what does that give us?
3.4.
Okay, and then exactly 3.4, is there more?
3.44.
Okay, 3.4. We're going to round to the second decimal place, which would be, so the 100 divided by 29. So, yep, that 8 is there, so I'm going to go 3.45. How would I label that? 3.45 what? What's in added? Strikeouts per walk. Very good. So for every walk, he had 3.45 strikeouts. So this is 3.45 strikeouts per walk. Whoops, that should be an R. All right, so what does he have in 2020? So we take a look. 2020, he only has 73 strikeouts. He has fewer strikeouts, but he also has fewer walks. So it's going to be close. So what is 73 divided by 20? What does that give us to the nearest 100? Okay, Aiden?
3.65.
Say that again?
3.65.
3.65. So he says 3.65. So 3.65. So he has 3.65 strikeouts per walk. So which year was he better? Which year was he better?
2019.
Why do you say that? What ratio is higher? Is 3.65 higher than 3.45?
Yeah.
Yes. And in this case, and you got to understand a little bit about baseball, you want more strikeouts than walks. So if you want to evaluate this performance, even though he had fewer, he did better because he had more strikeouts per walk. So in this case here, you would say 2020 was a better year than 2019, based upon that statistic. Now, you can always find different statistics to kind of slant things your way. But this would be one way to say, all right, I'm getting better. What if we use earned runs per inning? Okay, that's a key thing in baseball. Earned runs per inning. So in 2019, he had how many earned runs? He had 19 out of how many innings? 70. So you're going to do for 2019, what we say earned runs was 19 out of 70. What is 19 divided by 70? Nearest 100. It's going to be a decimal, obviously. 0.21?
271.
271? Okay, so that would be what, 0.27? So 0.27. So 0.27 earned runs per inning. Okay, see what you get for 2020. See what you get for 2020. And again, he has fewer earned runs, but he has fewer innings as well. All right. So Diana, how many earned runs did he give up in 2020? Off of the chart.
73.
I don't think so. Look at what's that? We want earned runs.
Oh.
For 2020.
Sorry. 19 over 50.
Okay, but here, make sure we're in this second part. We're just looking at 2020.
I'm so sorry.
It's all right. I just want to make sure you know where to look. So if you take a look, we want earned runs, which is 15 out of how many innings for that year? 50. So you do 15 over 50. Maddie, did you divide those?
Yes.
What'd you get?
0.75.
0.75? Oh, try that again.
This way. Yeah.
If you just said 0.75, it should be, you can't do that.
0.3.
Oh, okay. 0.3.
0.3, so 0.3. Or hold on here. So 0.3. So he gave up 0.3 earned runs per inning. Now, if you're not a baseball person, you might not know this exactly. What's better? Do you want to give up more runs or fewer runs as a pitcher? Fewer. So which year would be better using this comparison?
2019.
2019 would be better because you want to give up fewer runs per inning. In this case here, if strikeouts, 2020 is the better year. So depending upon what statistic you use, you could say one year is better than the other. So just make sure you come up with that, and you also label it. Is that the next one there? Okay, let's take a look at this last one. Comparing rates using points per shot attempted. The table shows statistics for a basketball player. You use rates to compare the player's performance in game 1 to his performance in game 2. All right, Mr. Parker, which stat looks a little extreme?
Yeah, just that.
Let's see. Shot attempts.
Yes.
Like got nobody else shot.
I know. This guy shot 47 times in game 1, and then he toned it down a little bit in game 2 because everybody's mad at him. Because that is outrageous. All right, but what are we comparing? We're comparing points per shot attempted. All right, so in this case here, for game 1, what should I divide? In what order? Okay, that make sure you understand this. Points per. Jeff, what do you think? What am I going to divide for game 1?
Would it be 37 divided by 47?
Good. You want to do the points first because it says points per shot attempted. So it would be 37 divided by 47. Zach, let me know what you get to the nearest hundred.
0.79.
Okay, 0.79, and that would be points per shot attempted. Holy cow. All right, game 2.
You wouldn't have played.
Game 2. All right, Emily, what are you taking a look at that? What do you think we should divide?
Repeat the question, I was still writing.
Oh, I'm sorry. Looking at game 2, if I follow the same comparison, what should I divide? Like I had 37 over 47. What should we do for game 2?
40 divided by 42.
No, because that's minutes played. How many? So we want points per shot attempted. So look at game 2. How many points did this person have?
26.
How many shot attempts did this person have?
26.
So we take 26 divided by 26. Hey, I can do that one. I think that's 1.0 or 1. So he had 1 point per shot attempt.
It's going to be shooting free throws.
Yeah, for that one. Yeah. All right, so that's how you compare. Now, so which game was he more efficient? Okay. Second game was more efficient, even though he didn't have as many points. He was better because he didn't shoot as many times, and he probably didn't get beat up in the locker room afterwards. All right, page 23. This is out of your book, 1 through 8. Now write this down because it doesn't tell you what to do for 7 and 8. You need to make sure you put that down because otherwise you could do anything. Now when you don't come and get your phone till the bell rings. When the bell rings, you'll come up and get it on your way out. Unless there's a different situation, and then I don't see why, but don't try and come up here during class. Wait till the bell rings and you get it on your way out.
Okay. I'm going to act like a ladder. I don't know how I got that. Found something for it.
He sent me an email said something about my today. I didn't realize he was absent. I got him for speaking. He never had. Yeah, that's what he meant. I didn't realize he wasn't here. I got to get that email.
It's on the community, I guess. Oh, I guess.
Yeah, he must have looked and there was nothing there. All right, hey, get some of this done.